Have you ever stopped to think about what actually holds the internet together? I mean, really holds it together? It's not just the fiber optic cables or the massive data centers. Nope. It's actually a clever bit of code, an idea from the early 90s that quietly saved the entire internet from collapsing under its own weight. So let's get into it. You see, back in the day, the internet was exploding. It went from this small, niche academic project to a global phenomenon, like overnight. But behind the scenes, there was this secret crisis brewing. The system for handing out IP addresses, the unique number for every single device online, it wasn't just inefficient, it was a ticking time bomb. We were literally about to run out of internet. And that created this massive question for the engineers at the time. How on earth do you build a system that can scale for billions of users when your most fundamental building blocks, these IP addresses, are disappearing fast? To really get the solution, you've got to understand just how bad the problem was. It all started with this system called Classful Addressing. Now, it probably seemed like a good idea at the time, but it almost stopped the internet's growth dead in its tracks. Okay, the best way to think about it is like this. Imagine you're selling t-shirts, but you only have 3 sizes: small, large, and extra, extra large. No medium, no extra large. So if a medium-sized company with, say, 300 employees needed addresses, what were their options? Well, they could get a small block of 256 addresses, which wasn't enough, or they had to take the large block of over 65,000. It was just insanely wasteful. And this chart just lays it all out. You had these super rigid sizes. A Class C with just 256 addresses, a Class B with over 65,000, and then this absolutely massive Class A with more than 16 million addresses. So, of course, almost everyone was forced to grab a Class B, use maybe a few hundred of the addresses, and just let tens of thousands of them go to waste. And all that waste created 2 emergencies at once. First, obviously, we were just burning through the available IP addresses at a totally unsustainable rate. But second, and this was just as bad, the internet's main routers were getting totally clogged. Their routing tables, which are basically the maps they use to send traffic, were becoming so huge and slow that the entire network was starting to choke. So the internet desperately needed a lifeline, and it came in the form of this really revolutionary idea. What if we just got rid of the classes? What if we could go classless? This timeline really shows you just how fast this crisis hit. The old classful system was set up in 1981, when the internet was still tiny. But just a decade later, as growth went through the roof, it was painfully obvious the system was broken. The problem got so bad that by 1993, the Internet Engineering Task Force, the IETF, had to rush in with a brand new standard to change everything. And they called it Classless Inter-Domain Routing, or CIDR. And yeah, it's pronounced cider, just like the drink. Its whole purpose was to tear down that rigid, wasteful class system and replace it with something flexible and efficient, something that let network administrators get exactly the number of addresses they needed, no more, no less. Now, the tech that made all this possible is called variable length subnet masking. I know that's a mouthful, but the idea is actually pretty simple. It lets you slice and dice networks into almost any size you want. It's the engine that gives a simple little piece of notation, a /, the power to completely redefine a network. And the way they did it was just elegant. It's this simple bit of notation that you've probably seen a million times, but maybe never really knew what it did. It all comes down to this /. This right here is CIDR notation. You've got your normal IP address, and then it's followed by a / and a number. That number, in this case the /24, that's the secret sauce. That little number tells you exactly how big the network is. So think of it like your home address. The number after the / tells you how much of the IP address is the street name. That's the network part, and how much is left over for the house number. That's for your actual computer or phone. It basically just draws a line in the address and says this part's the network and that part's the device. And this is where the magic really happens. A smaller number after the /, like a /16, means a big network, over 65,000 addresses. A bigger number, like /24, means a much smaller network with only 256. It's like a slider. You can just move that number up and down to create a network that is the perfect size, which completely eliminated all that waste we saw in the old system. But look, stopping the address waste was only half the battle. CIDR's second brilliant trick was cleaning up the internet's incredibly messy, bloated roadmap. Before CIDR, every tiny little network had to be announced individually to every other router on the planet. I mean, can you imagine? The routing tables on the internet's core routers were just exploding in size. The routers were getting slower and slower, traffic was taking these bizarre, inefficient paths, and the whole system was just grinding to a halt. CIDR fixes with something called Prefix Aggregation, or summarization. So instead of an internet service provider announcing 16 small networks one by one, they could now just bundle them all up and announce them as one single larger route. It's like the Postal Service advertising one route for an entire zip code instead of having a separate route for every single house. So much more efficient. You know, there's this quote from one of the original internet documents that just nails it. An address tells you where something is, but a route tells you how to get there. An address is totally useless if you don't have an efficient way to find it. CIDR fixed both problems in one incredibly elegant solution. So why are we even talking about a 30-year-old piece of technology? Well, because without it, the modern internet that we use every single day simply wouldn't exist. Its legacy is literally all around us. I mean it. CIDR is everywhere. It's the fundamental language of all modern IP networking. It's a core part of IPv6, which is the whole next generation of the internet. It's how virtual networks are defined in the cloud, on platforms like AWS and Google Cloud. And yep, it's even managing all the addresses for your laptop, your phone, and your TV on your home Wi-Fi network right now. In the end, CIDR is the absolute definition of an unsung hero. It's this invisible piece of infrastructure that solved a catastrophic problem before most of us even knew the problem existed, and it's still the foundation that keeps the internet stable and scalable today. It really was a brilliant fix, just a perfect example of elegant engineering, which kind of makes you wonder, as we connect the next billion people and trillions of new devices, what's the next CIDR? What's the unseen challenge lurking just around the corner that's going to need a similar stroke of genius to solve?